Evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Where tonight we're going to do a gentle introduction to Python programming with the TI-84 plus CE Python graphing calculator. My name is Mike Houston, and I'm the moderator for this event. I teach algebra, calculus, and statistics near Pittsburgh, where I use TI technology to make those tough to teach, tough to learn concepts accessible to all my students. Tonight, I'm excited to be joined by our two panelists, Becky Beyer and John Hanna. Becky is a nationally board certified teacher who teaches grades 9 through 12. Her current classes at Kelly Walsh High School include AP Statistics, AP Computer Science Principles, AP Computer Science A, C++, and Python. Becky, it's great to have you with us.
Good to be here tonight.
And John is a grandpa splitting his time between Ho-Pat-Cong, New Jersey, and Lakewood Park, Florida. He taught mathematics and computer science at Teaneck, New Jersey High School for 35 years as a longtime T-Cube instructor. These days, John gets his kicks from learning Python, supporting TI's product development teams, writing new programming curricula, and biking on the flat roads in Florida. And he wants to make sure we point out to be sure to check out TI codes. John, thanks for being here.
Greetings, especially to the guy from Jakarta.
John, will you talk through our agenda for tonight, please?
Yes, we just went through the welcomes and introductions, but I'll start off by talking about the big picture about what Python looks like on this TI-84 plus CE Python edition. Yes, it's a new calculator. And we'll get actually into coding, and hopefully we'll be able to go slow enough for you to keep up if you have a device or the SmartView software on your end of the line. We'll talk about writing if statements, loops, and simulations, and then get into the looking at more of the programming materials that are available online. And there are some handouts that are attached to this video when we're done.
Perfect. And be sure to stick around because we'll be giving away to one lucky winner tonight a TI graphing calculator towards the end. And Becky is going to discuss our expected outcomes.
All right, so by the end of tonight, you should know how to start your own project. You should know the difference between the 3 different data types, strings, integers, and floats, and how to get those into your calculators. You're going to learn how to read error codes and figure out which lines your errors are on. You're going to learn how to do some print statements. You're going to learn how to do some ifs and some loops and how indentations will help that out. And then finally, we will walk you through some menu options with some libraries.
Perfect. Thanks so much, Becky. We're expecting a large crowd tonight, so your audio is muted. Feel free to send any questions to John or Becky using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As John said, this session is being recorded, and we'll provide a link to that certificate of attendance at the conclusion of the webinar. And with that being said, John, you have control. Feel free to share your screen.
Thank you, Mike. And let's look at, share. Hopefully you can see my SmartView software out there.
Looks good.
Give me a nod. Okay. I'm going to start from scratch here because the big idea is this new calculator. It's the TI-84 plus CE Python edition. The SmartView software does not say Python up here, but the calculator itself has the word Python above the screen. What we're doing here in the emulator is showing you how to write programs in the Python world. We write Python programs by pressing the program key and invoke the Python app. Earlier, in the older versions of the calculator, it just went right into the programming system for only TI Basic. But now the new TI-84 plus CE Python edition has the Python app built into it. You must have the calculator that goes along with the Python app. You can't just put the Python app on a TI-84 plus CE. You have to have the new calculator to have the Python app work on it. So the Python app is divided up into 3 major workspaces. You're always looking at the file manager when you start. It says file manager at the top of the screen. And this is a list of the files that I have in my calculator right now. On the bottom right-hand corner, there's a key called manage. But these keys that are on the bottom of the screen are not clickable. What they represent are the top row of keyboard keys up here. The Y equals key over to the graph key are the keys that you press in order to invoke these software keys that are actually on the screen. So if I want to manage these files, I have to go down to a file that I want to look at. Oops, sorry. I'm going to press the down arrow key on my calculator, select a file here, and then when I hit the manage key, I can copy the program, delete the program, rename the program, look at the about screen for Python, or quit the Python app. I'm going to delete this program because I'm going to create it over again in a few minutes. And click the OK button by pressing the graph key because the word OK is actually right above the graph key. There's the file editor, which if you press the window key on your keypad, it brings you into the coding window, and this is where you write your programs. And then there's a run screen, which is called the shell. And I'm not going to run this program, so I'm going to press the on key so that I don't have to waste my time with it. The shell is indicated by these 3 greater than signs. That's called the shell prompt. And we can do stuff like 2 + 3 and press the enter key, and it's like a calculator, but it's the place where Python programs are run. So the 3 big workspaces are the file manager, the editor, and the shell. The editor is used for writing your programs. The shell is used for running your programs. And the file manager is used to manage the files that you have in your calculator. There's more about where these files are stored in your calculator, but you'll read about that more easily in the handout that we have provided along with this webinar session. There's a handout on getting started with Python, and the instructions for managing these files are included in that handout. So I'm going to quickly pass the torch over to Becky so that she can actually get you started with writing some programs.
All right, while John is doing that, and I'm going to share my screen in a minute, if you don't have your software turned on and you want to follow along, you might do that really quickly. So you'll notice I am right here at the blank screen when I've turned it on. I'm going to do exactly what John did a moment ago. I'm going to hit the program button, and I'm going to go down to my Python app. Whoops. I love when I do that. Oh, nope, I hit it right. Okay. I just have a lot of projects that are in there. From here, you can see all of my projects just like John's. I'm going to choose new. Like he said, I can't click on the new, which is kind of nice. It slows me down if I speed up a little bit too fast for people. Instead of clicking new, you're going to hit the zoom button. And I'm just going to give it a name. I'm going to type in area because eventually we're going to be doing an area project. And so I'm going to go ahead and get that typed in. And then to begin with, I'm going to say the types are optional. John will talk a little bit about types in a few minutes, but we're going to say that the types are optional. And so then I'm just going to hit the OK button. All right, so now I have a blank Python project. There's no code typed whatsoever. So for those of you who have done a little bit of coding, what is probably the first thing we should code? What's the first traditional project that you usually do when you learn a new language? Anybody know? Hello World, you are correct. Hello World is probably one of the first project languages you do because it's very simple, very easy. The only thing I have to teach you how to do is to print. So if you want to type the word print, you can, sort of. Like I start typing with my keyboard and I'm going to notice print isn't an option. So I could try to type around on the keyboard and type print out using my alpha keys, but it's actually a built-in feature. if you hit the functions, which is the Y equals key, you can go over to not control, not ops, not list, keep going, type, input output, and at input output, you're going to find the print command. So you could either type that in using your keyboard, or you can go to functions and go over to input output. And then from here, I'm going to type hello world. Hello world is a string, which means I'm going to have to use the quotation symbols. So you can either start by using all of your alpha keys and typing them out one at a time for hello world, which could take you a little while. Or you could use one of my favorite menu options. If I press the window, I end up with this great window option that will actually let me type the word hello world if I'm actually typing on a computer. It will also let the kids hit the buttons. You can use the arrow keys. So I can arrow key around, and right now I'm using my arrow keys on my keyboard, and I can arrow over and find the hello world. And sometimes that's a little bit quicker for kids. That's not a space back. Let's delete that. I think I have my chat window over the space. Maybe I don't have the space. John, I'm drawing a blank. Where's my space option there? Oh, two more
Top
over. How
row,
about
right
that?
hand side.
There we go.
There you
Two
go.
more over. Okay. So there's my hello world. If I get a little excitable and I miss my alpha world, you just hit the delete key, which is back on your keyboard. And then I'm going to close out my hello world with my exclamation. And now that I have everything typed, I'm just going to use the paste option, which is your graph button. And then I'm going to notice, oh, I started talking to you guys, and I typed the H, and then I went over to hello world. So you can use your arrow keys to back up and get your hello world typed in. Notice it's in green. All of the string that you use in Python is going to be colored green. And by string, I mean your characters. So if you have characters with words and numbers and symbols, if you put them inside quotes, Python is going to treat it like a string. And now all I have left to do is hit the run, which is your trace. And there's my nice little hello world. So there's your very first project in Python with a hello world. I can go back to the editor using that trace option. And now I can edit this program to do whatever I want it to do. So I'm going to just hit the clear button and clear out my hello world. The next thing you probably want to know is how to get information in from the user. So if I want to be able to, oh, I probably didn't want to clear that all out. I probably wanted to maybe be able to say, hello, John, or hello, Becky, have the user enter it. It would be awfully nice if there was a way to undo a clear option. There is. If you hit the tools, which is my zoom, you can undo a clear and it will bring back that last line of code. That's been a great lifesaver, especially because it took us some time to do that hello world typing. So now I'm going to just arrow up above it. And now I'm going to ask somebody for their name. So instead of saying hello world, I could say hello to whoever happens to be using my project. So I'm going to make a variable name. For ease of access, for now, I'm just going to go ahead and say A because it's a quick, easy type on my keyboard. So I'm going to say I want somebody's name. So they're going to enter that as input from the user. So I'm going to do a couple of different ways. I'll show you how to get the equal sign. One, you can hit the window button, go back to this the keys that we had, or the tools we had before, and choose equals. And then tell it to paste. And we'll do a different option here in a minute. Oops, I got myself out of my project. We'll go back and edit that. I don't know what I just hit on my keyboard. I didn't think I had my hand anywhere there. Now I'm going to get input from the user. I could type the word input, or I could go back to my functions. It's not a function. It's not those ifs. It's not the loops. So notice I can kind of scroll through my menus and look for the word I'm looking for, which is an input, which happens to be back in that input output. And then I could ask the user to enter their name by that same method we did before. And just use the quotes. And I'm just going to say name really quickly. not going to type the whole question. You could type the whole question if you wanted to. But I think for timing for tonight and getting through a few things, I'm not going to take up your time, especially for those of you who are typing along and you want to type in the whole sentence there. That might be a little bit easier. And now I can go down and I can edit that. And instead of saying hello world, I can say hello, comma, A. And whatever the user chooses to input, it will say hello to that person. So now if I run my code and I type in Becky, whoops, I always forget that. I have to use my alpha keys. If I type in my name and I hit enter, now it says hello, Becky. So our very first variable that we've stored is stored in A, and it's going to be stored as a string. Who knows the other two data types you could store? What are the other two data types in Python? All right, so floats, lists, and integers. So I'm going to agree with the float and the integer. Those are our two other data types. We can create lists, but our lists would be of either floats, integers, or string data types. So if I want to do math now instead, maybe I wanted to have them type in 3. I'm going to say, let's do 3 times their number or 2 times their number and do a little math and say, what is 3 times their input? An interesting thing happens if you haven't played with strings in Python before. If I type in 5, it's still asking me for a name, but if I type in 5 and I hit enter, if it stores it as a string, it does not do mathematical operations on it. Python kind of has this cool built-in feature that can sometimes get you into some trouble, that if you say 3 times a string, it will just write your string 3 times. So if I ran it and I typed my whole name back in there, which I'm just going to shorthand it here, it will actually print their name 3 times, because when you do multiplication onto a string, it will just repeat it. So if I wanted it to be an int or a float, I could arrow back in front, go back to my functions, go back to my input output. Oh, nope, just kidding. One next to my input output, my type. And then I could make that decision if I want it to be an integer, so a 3, a 5, a -7, a 2, so a whole number, but it could be a positive or a negative. So I guess it's an integer, right? We aren't math teachers, we know what an integer is. Or you could be a science teacher, an integer value there. And then floats are going to have decimal values. So if you want to be able to do math that has decimals, I would call it a float. If you only want them to be able to enter in integers, I would make it an int. So now if I change it to say float times input, enter name, it should say number, but we'll just leave it like that because I know you guys are typing along and that's a lot to type. Now when I run it and I type in the 5, I actually get the 15 that I was expecting. Okay, so those are kind of the basics of how to get some input and how to display on the screen. The next thing I want to show you is what happens if I have an error inside my code, how to read an error line. So let's say I meant to type in 3 times a minus some value and I forget to type that value in there. When you run your code, notice it gives me a traceback error and it tells me I have an invalid syntax on line 2. Anytime when you run your code, if you get a runtime error, a syntax error when you run it, it will tell you where it's at, giving you the line number. And it took me a second to realize when I first started coding that the line number is right at the top of your screen. Right now, my cursor is on line 1. If I move it to the next one, it's on line 2. So that's kind of a helpful feature, especially when you're helping kids. Sometimes the error is a little bit longer. Some of my kids today had errors that took up the entire screen and then some, and we had to scroll through it. But if you look for the line number, that will tell you where to start, and then it'll tell you what kind of error you're looking for. So that's kind of helpful. Okay, the first real, let's say real project, you guys have been writing projects all night tonight now. Our first real project is going to calculate the area for a rectangle. So we already have a good start to the area of the rectangle. I'm just going to delete and change this, instead of an A, just a B for the base of the rectangle. And then I'm going to go change my writing here. So again, it will say base. And again, I could type these out. I'm a fan of using the window button when I'm on my software, because then I can use my keyboard to type in base if I put my keys on my fingers on the right key. And then when I hit paste, it goes in a lot nicer. I could go to my menu and I could find float, that was under type, and I could find input, that was under the IO. But there's another great tool inside this tool menu when you hit the zoom button that will let me copy a line. So if you haven't played around with Python yet, this tool menu has some great options. Copy and paste line are two of my favorite, because after I copy it, I can go back to tools and I can say paste the line below. And now to me, it's easier to come in here and change. I wanted the base and the height. I'm going to go ahead and tell it to paste. And then I can go change this down below into my height. And then to insert a line, I just have to cursor over to line 3 and hit enter. And then I can do my math operation here, so I can recycle that area variable that I wanted to use. And then I told you there's a couple different ways to get the equal sign. You could hit the Windows button and go back into the menu that had all of the letters in it, or you can actually just hit the math button itself. Oh, just kidding. Not the math button, Beck. What are you thinking? About the test button. In the test button, it has all sorts of symbols for us. The test button has the equals. That's if you're going to store, and I like the tooltip on the side. I don't know about your students, but my students forget when to use the equals and the equals equals. In Python, if you want to store a value, you're going to use the equals. If you want to test equality, it's the equals equals. Exclamation equals is how you test to see if something is not equal. And then you have your greater thans, your less thans, your ands, your ors, and your nots. So this second test button is really a nice tooltip as a shortcut to give you all the different options there. So I'm just going to say A equals, and then here's my base times my height. And then it's up to you. You could just tell it to print A. I like my students to have some descriptive output. So usually we will go back in and we will use the quotes and we will have them label their answer. So here's my area with a comma, and then the variable that stored that was an A. And by having that labeled, when it prints, it will print the nice label. The comma, this is a built-in function that will add a space. So there will be a space break between the area and the A. And so when I run it, if I say I have a base of 5 and a height of 7, I end up with an area of 3.5. One thing to notice, I typed in 2 integers, but because I said store them as a float, my answer is a float, because you do have a float times a float gives me a float back. All right, so there's a couple of basic things. From here, it might be nice to maybe find the area of a rectangle and find maybe the area of a circle. Give the students the 2 options in their choice. So if I want to let the user pick if it's an area of a rectangle or the area of a circle question, I'm going to need a new piece of syntax we've not talked about tonight, and that's going to be the if statements. So to do an if statement, I am just going to go to the top of my code here and add a couple of lines. And I'm going to give the user the option for what they want to find. So I'm going to say option equals and paste that. And I'm going to ask the user, do you want to have a rectangle or do you want to have a circle? I don't want to have to type the whole word input. So I'm going to go use my functions to go back to the input option. And then if I'm just going to limit it to those two options as to whether or not it is a rectangle or a circle, I think for tonight's ease of typing, for those of you who are typing along, I think I'm just going to do an R with a space and then type the word O or and then a C. So do you want a rectangle or do you want a circle? Again, it's string, so it's going to be printing something to the user. You have to use the nice little exclamation or the quotes. And so now I have my options. So I'm going to do an if, elif, else. So if it's a rectangle, calculate the rectangle. If it's a circle, calculate the circle. And if they type in something that's not an R or C, tell them that wasn't an option. So again, this is one of the greatest, I think, tools out there is this functions button. If you're not sure what the syntax is, if you hit the y equals for a function, if you've coded before, you know you're looking for an if. So as I move over to the control, I have the option for an if by itself, an if or an else. So if I have two options, in this case, I'm going to have three, an if, elif, else. That took me a little bit of getting used to. I don't know about the rest of y'all, but if you've coded in other languages, this elif kind of threw me for a loop for a second. So I'm going to say if my option is an R. So again, I can type that OP either using the alphabets, or I can just type it using my keys. Then I'm going to hit my second test button. And now I'm doing equality. I'm not storing. And again, it's got that nice little tech tip to tell me I'm checking to see if they're equal, not storing. So I'm going to say if it is an R, but then I'm going to say, whoops, Beck, you forgot to put your quotes in the front of that. It's a string. And if I want to check string versus string, this guy's got to have the quotes around it. So if it's an R, well, I need to do these guys down below, and good golly, it didn't pop it into the right spot. But there's that great tool that will let me cut a line, and then it will let me paste that line right where I need it to go. And then I can do the same thing down below. I can cut a line, and I can paste it. And so even though we have it all typed out, I don't have to delete it and restart things. I can use the cut and the paste feature to move objects around, which has been a great time saver for students, especially when your students are first starting or you're first starting and you're like, oh, I wasn't quite thinking about how the order of that needed to go in my code. It makes it easy to move things around.
Talk about the
All right,
indentation for a moment.
Oh, good call on that, John. So in Python, we don't use curly brackets to keep everything together. You use one level of indentation, and if you were going to put a loop with this, you'd have two levels of indentation. What I think is great for my old eyes is the two diamonds that show me that they're indented. So if you're error checking with students, it will throw an error if they don't use two spaces for an indent. So if I do something like that and I knock my print out one indentation level, these guys will be all part of the if statements. And then this guy is actually neither part of the if nor non the if because it's not spaced correctly. But you can just go add those back in on your catalog. Inside the tools, there is an option to help you indent if you need to indent a level or unindent a level, dedent, like so. But everything has to be tabbed in, and that's how you use curly brackets in some languages. It's just a nice little tab. All right, so next option, I'm going to come down and I'll do the other option. And then we're going to say equals equals, which is a test. And then we'll put in a C for circle. And then I'm going to copy what I've already coded, because why would I want to type it all over again? If I can just recycle with a little bit of a tweak. Oh, I did not paste it. Thought I pasted that. Copy a line. Paste a line below. So now instead I'm going to do a radius, and for time I'm going to just ask for R. And then we're going to have a great conversation. I picked a circle on a reason. If you're going to find the area of a circle, what is the formula, y'all, for finding the area of a circle? That might be a silly question. So somebody has typed in the window pi times r with the caret symbol 2, and unfortunately, that is 100% correct, but will get you in a little bit of trouble in Python. In Python, we don't use the caret symbol. Does anybody know what symbol you use in Python for exponents? It is the times sign. You are correct. So it's not the caret symbol. If you use the caret symbol, it's going to do some bitwise operation. You don't want to do that. So I'm going to go ahead and type in 3.1415. We'll do an approximation times the radius. When you try to hit the squared button, it will automatically type in that times for you, so you don't have to remember that. But it is kind of an eye-opener for kids when they hit that the first time. They'll try to figure out they'll think that they hit something wrong. So it's kind of important to make sure that you point that out with kids. So yeah, the times is how you're going to do a squared in Python. And then I can just copy that line. I can paste it down below. And then inside my else statement, the last thing I'm going to do is I'm just going to print invalid. And notice, since I'm on software, it's really easy for me to just type in here. And paste it. And now you have a completed project. If you were able to keep up with me, I got a little quick there at the end, but if I run it, I can type in that I want to find the area of a circle. And I type in the radius is 3. And there's my area. I can go back and rerun the project. And I can say I want to find the area of something called B, and that's not one of the options. And it tells me it's invalid, like so.
Explain how you reran the project.
So I'm sure that, John, you probably have a shortcut for that, but I hit the run button and then I typed in my option and hit 5. And then for me, it's just as easy to hit the trace to go back to my editor and to rerun, but I'm sure there's a shortcut. What's the shortcut, John?
I do the same as you.
Oh, do you? Oh,
Yes.
I thought you were going to have a shortcut on the keyboard there.
Nope. On the tools menu, there is also a rerun command at the top of the tools menu.
Oh, I did not know that. I learned something new from you tonight. There we go, y'all. All right, so with that, I am going to pass it off to John to finish up tonight. Oh, somebody asked a really good question. Would R cubed be star, star, star? R cubed would not. You would just do R star, star, and then a 3. So you just use the 2 stars anytime you wanted to use the caret key.
Okay, here we go. What I'm going to write a new program here. I'm not accustomed to working with this large screen on the right-hand side. Usually, when I'm working this on Python on my own on the calculator, I like to work with it this way because I'm always tempted to press these buttons on the screen rather than the keys underneath it. So this reminds me that I'm supposed to press the zoom key to start a new program. But we're going to blow this up and bring this back on the screen over here so we can see it again. And the name of this program, I'm going to write a program that does a probability simulation first. And we want to flip a coin and count the number of heads that are tossed in a certain number of tosses. So we're going to call it program heads, H-E-A-D-H. Go on here, H-E-A-D-S. And just so you know, I'm pressing the keys on my computer keyboard to get that word in there. An important thing about putting in the file name first is so that your file is saved as you type. You don't have to save the document as you go. It's automatically saved for you. If you've ever done any basic programming on the calculator, it works the same way. You type in the file name first, and then every character that you typed is automatically saved on the fly. Becky mentioned the types option down at the bottom of the screen. The middle key on the soft keys at the bottom of the screen is called types. And if I press that key, we can start out with a blank program, math calculations, random simulation, plotting. The Python system can do graphical plotting for you. Data sharing. An important feature of the Python system is that it's a totally separate environment from the calculator. Data sharing means you're going to share a Python data with the calculator's files and vice versa. You can pull in lists from the calculator and use them in the Python side of the calculator. It's two different worlds, the Python world and the calculator world. A hub project is for using the TI Innovator Hub, and the rover project is using the TI Innovator rover system, the robotic system. And then these are some utility files for working with the STEM project that are available on TI's website. I'm going to do a random simulation, so I'm going to choose this random simulation from this list. And at the bottom of the screen, instead of saying optional now, it says random simulation above the word types. If I press the OK key or the Enter key on my calculator, I'm now in the program editor. The file name is at the top of the screen and you're working in the editor. I'm on program line 3 and I'm going to toss a coin a certain number of times. And I'm not sure how many times that's going to be. So I'm going to write this as a function, which will let the user enter the number of tosses when they execute the function. Functions are a powerful idea in Python because they can be used to return a value, say return x squared, and it would produce the value of x squared or some other function that you choose to write. Or they can be used as subroutines within your program and execute a whole lot of code, Python code, from within that function. And it doesn't even have to return anything. It can just do the work over and over again. So when I press the FNs key, the first submenu in this screen is the function submenu to define a function, and then the return statement is also found on this same menu. When we define a function, notice the indentation on the next line. I first have to name the function. I'm going to call the function. I'm going to use the second alpha key here to turn on alpha lock right here in the editor. And I can type in here H-E-A-D-S. And then inside the parentheses of the function, I have to supply an argument. I'm going to use alpha is already on. So I'm going to type the N key here so that N will represent the number of tosses there are going to be. Notice that my alpha mode is still on and it's in lowercase. By the way, did you notice everything in Python here is lowercase? You can have uppercase characters as well if you press the alpha key again. Then the cursor is blinking with a capital letter A instead of a lowercase a. And you can use capital letters, but more often than not, you're never going to use capital letters again in Python because lowercase letters work just as well. And the TI-84 Python edition supports all of these lowercase letters as well. I'm going down to the next line in here, and we're going to have to toss the coin that many times. So I'm going to use a for loop by pressing the functions key, the y equals, go over to the control menu and choose one of these several different variations of the for loop. The first one is the one I'm going to be using. But an important feature about the for loop in Python is that this range argument must be an integer. So if you use range alpha n, alpha is still on. I have to keep an eye on that cursor to let me know if it's still on. N has to be an integer. You can't put in a decimal value there or a floating point number. If you want to go from 2.3 to 5.7, you cannot do that in Python. You'd have to use a while loop instead of a for loop, or write an expression that will convert 23 to 37 and then multiply the value by 10 each time. There are workarounds, but that range function is limited to integers only, and it will produce integers only for you. Now we're going to use that random number generator. Since we have the random number file imported here, we're a little bit more about importing. Python is very lightweight. That is, there's very little included in the core language. So randint or uniform or random number generator itself are not part of the core Python. It's part of a standard library. I'm going to press the math key and look at these modules. Oh, I have alpha lock on. Delete those two things. Turn off alpha lock by hitting second alpha. And on the math menu, these are the modules that come with your Python system. The first three are standard Python modules. Math contains math functions, including pi and e. Random are random number generators. Time includes some time functions. And the last four are TI provided special modules that work specifically for the TI-84. TI system module has some special commands in it. The plot lib is for graphing, and the hub and the rover are for the innovator hub and for the rover. But all of these modules, or any of these modules, must be imported into your code. And that's usually done at the top of the program. So that's from random import star means I now have access to the random number functions that are in the random module. So in here, we're going to count the number of heads. But I'm going to count the number of heads without using an if statement. And this is the tricky part about writing this particular program. I'm going to say alpha s for sum. Where's s? Over here. Equals, and I'm going to use the store key for the equal sign. And then alpha s again, which is going to drive math teachers crazy. Plus, and now a random integer, either 0 or 1. 0 is for a tail, and 1 is for a head. To get the random integer function, randint, I press the math key, look at the random module that I imported before, and choose randint from this menu. A word about the others. Random is going to generate a random number from 0 to 1. It doesn't take any argument. Uniform is a random decimal from a lower bound to an upper bound, min to max. And randint is a random integer between min and max. So you're going to use randint. Notice that the comma is provided for you in there. So I'm going to type a 0 and then a right arrow. I don't need to type the comma, and then a 1. I'm going to hit, notice how the for loop is indented an extra 2 spaces. So the function is defining, has 2 spaces indented. The for loop is also indented 2 more spaces, but now I want to back out of the for loop so that I can use the return statement for the function. So I'm going to delete 2 of these dummy spaces in the front here and invoke that return statement from the function menu. Press the functions key. On the function menu, select return and alpha S. Anything else I need to do? I expect an error here, so be patient with me. I hit the run key and nothing happens. Because I defined it as a function, that function is now defined, but it's not being executed. Press the vars key, V-A-R-S, and notice that the function heads is listed on the screen. That's the only variable or function that's defined right now. When I press the enter key to select that function, and then I put in 10 as the argument of the function, and press the enter key, I get an error message. And again, what Becky mentioned before is error messages are really common in programming, and it's up to you, the programmer, to decipher what this thing means. Name error, local variable referenced before assignment. And it seems like it happened on line 6. So we go back to the editor, take a look at line 6. Notice the line numbers at the top of the screen. And it says S equals S plus. And the error is that I never initialized the value for S. So I'm going to do that in the function at the beginning. What do you think S should start out as? 0. So S starts out with 0. I type the alpha S. The equal sign is from the store key, and then the number 0. And run the program again. Nothing happens on the shell. So I have to press the vars key to find my function. Select heads, put in 10. And out of 10 tosses, I got 2 heads. To rerun this program, I can just press the up arrow key, go in here and try a different number. I'm going to change it from 10 to 100. I'm going to toss a coin 100 times, press the enter key, and I got 51 heads this time. Let's try 1,000. Toss a coin 1,000 times, and how many heads will I get? 494. And I'm going to skip on ahead. The last one I want to do is 1,000,000 times. So I'll add some more zeros in here. If I toss a coin 1,000,000 times, how many heads do you expect? I'm amazed at how fast that happens. It only took about a second or 2 seconds to generate a 1,000,000 coin tosses and count the number of heads. The reason this program works so fast, if I look at the editor again, here's the entire program, is that it just does a for loop and accumulates the random integers that are zeros or ones. So it's counting the number of heads. By the way, it can also refer to counting the number of tails too. Since the probability is the same, you're going to get 1/2 of the time you're going to get tails, and 1/2 the time you're going to get heads. But the idea of defining a function and returning a value is a powerful tool for Python. We can write more functions in this program by starting it over at the beginning. Press the functions key, define another function. We'll call it dice. So we're going to do second alpha. And we'll call this one dice. And we'll return, I'm just going to use a return statement in here. So we hit the functions key, choose return, and use a random number from 1 to 6. So we hit the math key for the modules that are available. Whoops, I have alpha on. I keep forgetting to turn off alpha lock before I do that. Second, alpha. That's one of the advantages of using that character map that Becky was using before. The window key brings up this character map and it forces you into alpha mode only while this screen is active. And once you hit paste, then it returns you and you're not in alpha mode anymore. Math, random, rand int, 1, right arrow, 6. And that's a second function. When I run the program this time, if I press the vars key, there are now 2 functions defined, dice and heads. Each one does its own little job. If I choose dice, and I don't have any arguments in that function, when I press enter, it produces a value of 2. If I hit up arrow, I can rerun it, hit up arrow, rerun it again, and each time it'll generate a random number from 1 to 6. And you can see where this can go with statistical analysis and everything else. You can build a whole dice simulation around this particular simple function. I don't have a lot of time left, so I'm going to do one quick demonstration of, I have to get the graph key, and I don't have it on my screen here, so I'm going to start a new program, call it darts. Oops, I forgot to choose what type it is. So I'm going to press the math key and import the random number generators. The first item on this menu is from random import star. I'm going to use a for loop to toss some dice. Let's use the new loop. On the TI system menu, there's a command called while not escape. But in order to use this tool, this command, I have to import the TI system menu as well. So I press the math key, and on the TI system menu, I'm going to choose from TI system import star at the top of my code as well. While not escape means as long as you haven't pressed. But you notice that on your TI, I'm going to toss a dart. I'm going to, here's my picture. Here's the big idea. Let's do this key. I have to go on my desktop because my picture is showing in here somewhere, right here. This is my dartboard, and it's a square, 2 units on a side, with a unit circle inscribed in it. When I toss a dart at this board, if it lands inside the circle, I'll count that as a hit. That's a bullseye. And if it lands outside the circle, it's a miss. But all of the numbers that I generate, all the points I select, are going to be between -1 and 1 in the X direction and -1 and 1 in the Y direction. So back to my code. I'll leave that on the screen over here so you can see what I'm referring to. Back in my code, I'm going to say alpha X equals, and then on the math menu, we choose the random number generator, rand int, -1, (1). Oh, we don't want rand int. Mistake. Delete that. Because those are just -1, 0, and 1. Instead of rand int, we want to use the uniform numbers, which are the decimal values between -1 and 1. So it gives me an extra set of parentheses in here that I'll just delete. Uniform -1 to 1. And then, like Becky did before, I'm going to copy this line and paste it below. And change it to Y instead of X. So delete the X and type the Y. Did I delete the X? No. And then if it's inside the circle, then its distance from the origin is less than 1. So we write an if statement, if and then x squared plus y squared. So we do alpha x. There's an x squared key on your keypad. Watch what happens when I type this x squared key. I get star star 2 plus, and then I hit the alpha y and hit the x squared key, and I get another star star 2 is less than 1. So we do the test menu, second math, choose less than 1. And then we're going to add 1 to the number of hits. I haven't defined what hits is yet, but it will be H, alpha H. And then I'm going to use a shortcut here, plus equals 1. This means add 1 to H, or H equals H plus 1, but it's a shorthand notation which simplifies things a lot. So up at the top of my code, I need to start off with an initial value of H. Alpha H equals 0. I also want to count the number of darts tossed, not just the hits. So I'm going to have to use another letter, alpha D equals 0. And each time I generate a random number, I want to increment the value of D. So in the beginning of this code, I do alpha D plus equals 1. Whoops, what happened to alpha D? I didn't have alpha mode on. Delete, 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 delete. That happens to me a lot. Alpha D. And then I look up at the screen and say, what did I type? At the end of this program, when I press the escape key, I'm going to print. Remember where print is? On the functions menu under IO, there's a print. And I want to print alpha, the number of hits, alpha H. I'm going to keep it simple because I'm running out of time, comma, the total number of darts, alpha D, comma, and then the ratio, the hits over the total number of darts. So that's alpha H divided by alpha D. So be aware, this is not a function this time. It's a raw program that will run as soon as I press the run key, assuming there are no errors. And I have to press the clear key to stop this loop. When I do that, it'll print something on the screen, hopefully 3 numbers. So I'll press the run key. Nothing is happening, but the program is running until I press the clear key, in which case I get 80 hits out of 100 tosses for a ratio of 0.8. In the long run, then what number will that approach? And to make it even more clear, I'll go back into the editor and multiply this value by 4 instead of taking H over D, put in 4 times H over D and run that again. Wait a few seconds. I got to pass the torch to Mike. I know he's chomping at the bit. Press the clear key on my code. So I got 90 out of 119 for an approximation of 3.02. In the long run, the ratio will be the area of the circle divided by the area of the square, or pi over 4. So when I multiply that ratio by 4 in the editor, this number should eventually approach pi. And so this is another random simulation that uses a program rather than a function. There's more about this simulation stuff in the handouts that I've provided. and it's available along with the other code, other materials that Becky has uploaded as well. So I've got to pass it back to Mike because we ran out of time here. And yes, to Mike. Thanks for being patient.
Thanks so much, John. As mentioned earlier, tonight we're giving away to one lucky winner a TI graphing calculator, and tonight's lucky winner is Heather Albrecht. So Heather, congratulations. We'll be in touch soon over email to get a little more information from you about which calculator you're going to choose. To receive your certificate of attendance, go ahead and click the link in the chat window. Also listed as a link for the documents that John was just referring to a few moments ago. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Thanks so much, John and Becky, for the gentle introduction to Python and for putting everything together for tonight.
And thanks, Mike, and thanks, folks, for sticking around.
Agreed. Thanks so much, everyone. We hope to see you back online real soon. Have a great night and stay safe.